Today our topic is partial derivative application as maximum and minimum values like extreme values of the function. Let's start from the extreme value. The point at which function f of xy is either maximum or minimum is known as the stationary point. The value of the function at the stationary point is known as extreme maximum or minimum value of this function. Working rule for the extreme value of the function f of xy. First, we have to find del f by del x and del f by del y. For the maximum or minimum values, take del f by del x equal to 0, del f by del y equal to 0. Solve these simultaneous equation del f by del x and del f by del y equal to 0. Let a, b, c, d be the solution of this equation known as a stationary point. Find del square f upon del x square equal to r, del square f upon del x del y equal to s, del square f upon del y square equal to t. Now find rt minus s square at the point a, b, c, d separately to the following condition. First, if rt minus s square greater than 0 at the AB, then the function is either maximum or minimum. If r greater than 0, then the function is minimum at the AB and minimum at the function f(ab). R less than 0, then AB, then the function is maximum at AB and maximum value of the function of AB. If r equal to 0, then nothing can be said about the maximum or minimum. This is the condition for the first r if rt minus s square is greater than 0. Okay. If we are taking rt minus s square greater than 0, then check these three conditions. After that, we are taking second. If rt minus s square is less than 0 at point AB, then function is neither maximum nor minimum at AB. Such point is known as a saddle point. If rt minus s square equal to 0, then nothing can be said about the maximum or minimum. Find the extreme value of the function. First is a function x cubed plus 3xy square minus 3x square minus 3y square plus 4. If any, then find these values for this function. Taking f of xy, x cubed plus 3xy square minus 3x square minus 3y square plus 4. So del f by del x equal to 3x square plus 3y square minus 6x. What is our del f by del y? It is 6xy minus 6y. Now we have to find extreme value. Then del f by del x equal to 0 and del f by del y equal to 0. Solve this example. Solve this equation simultaneously. 3x square plus 3y square minus 6x equal to 0 and 6xy minus 6y equal to 0. So what is our equation 1? It is x square plus y square minus 2x equal to 0. And in second equation, we are taking 6y, x minus 1 equal to 0. So y equal to 0 and x equal to 1. Putting y equal to 0 in equation 1, so we get x square minus 2x equal to 0 and x equal to 0 and 2. Stationary points are, if we are taking y0, then two values are the stationary point. One is 0, 0. When y-axis is 0, x-axis is 0. When y is 0, then x is 2. These two possibilities of the stationary point. Again, putting x equal to 1 in the equation, x square plus y square minus 2x equal to 0. 1 plus y square minus 2. So y square minus 1. So y equal to 1 and y equal to minus 1. Now we are taking x and y as a stationary point. When x equal to 1, y equal to 1. When x equal to 1, then y equal to minus 1. So both are the possibilities of the next stationary point. So we getting total 4 stationary point. 1, 0, 0, 2, 0. In second one, third one, 1, 1 and 1 minus 1. Now check the value for the extreme value. For that, we have to find del square f upon del x square as a r. So we get 6x minus 6. Del square f upon del x del y, it is s, we getting 6 pi. Del square f upon del y square equal to t as a 6x minus 6. Now what is rt minus s square? 6x minus 6 into 6x minus 6 minus 6y whole square. By putting stationary point 0 0 2 0 1 1 1 minus 1 for xy 0 0, we getting rt minus s square, it is 36 greater than 0. Function is either maximum or minimum, but r equal to 0, it is less than 0, so function is maximum at a point 0 0. See, we take the condition if rt minus s square is greater than 0, in that case r is less than 0, then function is maximum. Okay, now for function x cube plus 3x square minus 3x square minus 3y square plus 4, we put the value 0 0. Maximum value of function is 4. Okay. Now rt minus s square, again putting value of stationary point 2 0, then we get it is 36, it is greater than 0. So function is either maximum or minimum. Now find what is our r. R is 12 minus 6 equal to 6 greater than 0. So function is minimum at a point 2 0. Okay. Now put the value of function 2 and 0 in the function. So function at minimum equal to 8 minus 12 plus 4 equal to 0. So it is 0. Now check for the stationary point 1 1. Put the value in rt minus s square. It is minus 36, it is less than 0. Function neither maximum nor minimum because it is less than 0. And point 1 1 is called saddle point. Now last point 1 minus 1, we have to check for the equation 1 minus 1, put this value in rt minus s square. It is minus 36 less than 0. So function neither maximum nor minimum, and it is become a saddle point. So see here in the table xy, we take in first point 0 0, put the value in rt minus s square and check the condition of r. Conclusion is function is maximum. At that point answer of the function is maximum value is 4. Then again we check the stationary point 2 0, put in rt minus s square, it is also greater than 0. Then check the condition of the r, and r is greater than 0, then conclusion is it is minimum. If it is minimum, then put the value in the function, we get is a minimum value of the function. xy equal to 1 1, put the value in the rt minus s square, it is less than 0. Then don't discuss about the r because of conclusion is neither maximum nor minimum, it is saddle point. Similarly, in the fourth case 1 minus 1, it is also less than 0, so it is saddle point. This way we are getting the extreme values of the function. Find the extreme value of the sin x plus sin y plus sin x plus y. Sin x plus sin y plus sin x plus y. What is our del f by del x? First point is del f by del x. That is cos x plus y. Del f by del y cos x plus y. For the extreme values, solve these equations simultaneously. Del f by del x equal to 0, del f by del y equal to 0. Now take this equation 1, cos x plus y equal to 0 and cos x plus y equal to 0. Both are the equation 1 and 2. Equation 1, we are equating them, then we get cos x equal to cos y. So x equal to y. Substituting y equal to x in equation 1, we get cos x plus cos 2x equal to 0. So cos x equal to minus cos 2x. Now, as that case cos 2x is written like as a cos pi minus 2x or pi plus 2x. So x equal to pi minus 2x and x equal to pi plus 2x. So 3x equal to pi and minus x equal to pi. So we getting value of x equal to pi by 3 and x equal to minus pi. So y equal to pi by 3 and y equal to minus pi. So what is our stationary point? There is 2 points. Because we taking a condition x equal to y. So x as a 5 by 3, then y is a 5 by 3. If x equal to minus 5, then y equal to minus 5. Now find del square f upon del x square equal to r minus sin x plus y. Del square f upon del x del y equal to s equal to minus sin x plus y. Del square f upon del y square equal to t. It is minus sin y minus sin x plus y. And what is our rt minus s square? Equation is minus sin x plus y minus sin y minus sin x plus y minus sin x plus y whole square. Okay. For this point, we taking value xy pi by 3 put in the equation rt minus s square we getting 9 by 4 greater than 0. If value is greater than 0, then check the value of r. What is our r? R is under root 3. If r is under root 3 minus under root 3 and it is less than 0, then conclusion is that the saddle point, then the stationary point pi by 3 is a maximum. The function is maximum at the value 3 under root 3 2 as per the table. Similarly, for the minus pi, rt minus s square is 0, so nothing can be said. Okay. Some examples we have put on the board to solve using this concept. Find the extreme value of the function with this. Thank you.